This week on Waterways, scientists seeding coral colonies in South Florida, and the Free Florida Bay Map and Guide. Corals serve as the infrastructure for a magical underwater world, teeming with life and color. Coral reefs create shelter and feeding grounds for almost every link in the food chain. When baby corals, or larvae, are set free into the water column, they are at the bottom of that food chain. Everything from worms to fish eat them. If they survive the feeding frenzy, they are quite picky about where they will settle down. Not all corals are created equal. Different species have evolved different ways to cope with reproductive challenges. Wade Cooper, a graduate student at the University of Miami's Rosenstiel School, is trying to figure out what makes some corals more successful at colonizing the reef than others.
The species we work with is Porites asteroides, the common mustard hill coral. It's one of the most common corals in the Florida Keys, very common in the Caribbean too. It's also one of the best recruiters in the Florida Keys, which is one of the reasons we like to work with it, to try to identify what are some of the behaviors, properties of this species that make it a good recruiter. One of the main things we're trying to accomplish with this work is to increase the amount of recruitment on the bottom using these seeders as a small-scale restoration technique. We started approximately 2 months ago with 1,000 larvae, and we currently have up to 100 of them surviving. We're hoping to increase this amount and within the next year get many hundreds of larvae surviving on the bottom, even after a year's period of being out there.
Studying coral reproduction can be quite frustrating. There are logistical challenges like renting a boat at night or facing bad weather, and there are biological issues. The window for coral spawning is very small. Most corals only spawn during a couple months of the year, and only during a few nights of those months.
Corals have several ways that they propagate themselves. There are corals that are broadcast spawners. That means that they release their spawn to the water column. It gets fertilized, and that spat then drift away. Or they're brooding corals, where the coral larvae are actually brooded in the tissue of the coral, and once they're viable to live in the water column, then they get spit out and generally settle very close to the original colony. We're really in the beginning stages of starting to understand that. There are a few researchers like Wade Cooper that are looking at how does coral settle, what are the cues that corals need to settle, and how do they manage to keep themselves alive through that first couple of years when they're basically the most yummy thing on the reef.
To answer these kinds of questions, researchers collect coral larvae and study them in the laboratory. Capturing coral spawn in the field is difficult. Some researchers set up tent-like nets over corals that must be checked every day. If left out too long, predators can eat the larvae. Pounding waves can shred the nets, or the water in the traps can become stagnant, killing the larvae. The trick is to catch enough larvae and get them back to the lab alive to perform settlement experiments, a feat that is not always successful. To get around this, Wade has taken a different approach.
With our corals, what we're doing is we bring them back into the lab to collect the larvae from them as a release from the adults. One of the main reasons, last year we actually tried collecting from the field, but we were chased out by the weather a few times where you can't get out and actually collect them every single day. And that is a key point. You don't want them to leave them in the containment traps for a long period of time. You ideally want to collect them, check the traps every single day, which sometimes you can't do in the field due to weather issues.
To get a more reliable result, Wade and his team collect adult corals in Biscayne National Park and bring them back to a special holding tank in their lab. Under the supervision of park scientists, Wade is allowed to borrow some coral colonies for a few brief periods each year to catch their larvae when they spawn.
Once we collect the larvae over the period of a week, we then take the colonies and we reattach them to the reef using hydraulic cement. So it's a way that we aren't actually losing much coral tissue in the process from the time we chisel them off, bring them into the lab, collect the larvae and take them back out. But what we are gaining out of this is that we do collect the larvae, and hopefully over time we'll perfect these seeding techniques that we can increase the number of corals on the bottom.
By having a reliable source of coral larvae, Wade can observe how larvae in the lab develop and where they like to settle. This provides clues about what may or may not allow them to colonize the reef.
Some of these small experiments we have going, we'll settle them out on little chips in the different treatments that we have, and then we're able to map out these larvae on these little chips using fluorescent lights or using the microscope, using different techniques to see where they actually settle out, and we can follow them over time to see how different stressors affect them in the lab.
The rest of the larvae are returned to the field to be seeded on the reef. They are injected into small structures that limit the area where the larvae can settle. With the naked eye, a coral larva is nearly impossible to find if you don't know where to look. If you know, you can track an individual larva from the first day it settles. These early, invisible days of coral's life are the most difficult, and very few make it to adulthood, and scientists want to know why.
Once we settle out the larvae using our seeder devices in the field, we can pull off the seeders after we give them a couple of days to actually settle on the bottom, find a good spot, and then to follow them over time, it's somewhat tricky. You can't see them with the naked eye, especially in the reef substrate, which is a very complex substrate, lots of little nooks and crannies they can hide into. To get around this, what we've turned to is using fluorescence. People in the past have used fluorescence at night because you can easily see it. You go out and you do a night dive. But we don't have the opportunity to take night dives every few days because of logistical issues.
When a fluorescent light is shown on a larva at night, it will glow, making it much easier to find. During the day, however, it's a different story.
What we've tried to develop as a technique to census these individuals throughout the day, we've made a custom dark box that we can actually hold a fluorescent light within and see the bottom, which we've dubbed the Vader bucket, visual apparatus for detecting recruits. With this bucket, we can actually map out the individual spat, where they settle, by hand on a piece of paper, and then follow them over time. Every few days come back, see which ones have survived so we can get a quantification of these early mortality rates, where they like to settle, and also how well they do after they settle out on the bottom.
Tracking larvae as they grow on the reef and in the lab isn't just an exercise in science. Clues to coral survival may have practical applications to reef restoration in Biscayne National Park.
We have a number of groundings throughout the year. About every 5 years or 6 years, there's a large grounding where a 300-400 foot vessel comes up on the reef and damages a large area of the reef. But most coral reef groundings require some degree of restoration. That can range anywhere from just reattaching the corals that have been broken off the reef to actually going out and rebuilding structure. And that's one of the problems we have right now in coral reef restoration throughout the Caribbean and probably throughout the world, is that we don't have the materials that we need to rebuild structure.
After a boat grounding, managers try to repair the reef by finding ways to fill in the damaged craters. Corals have an extremely slow growth rate, on average less than ½ an inch a year. It could take large reef-building corals a person's lifetime to fill the holes left by a boat grounding. Because of this, scientists are looking for shortcuts to help the reef recover more quickly.
Researchers or managers throughout the Atlantic coral reef ecosystem are literally going to the reefs nearby and collecting corals from those reefs and moving them onto the structure that they've built after there's been a grounding. Which is okay in the fact that you're not killing coral, but what you're doing is causing damage to repair damage.
The challenges, in addition to coral's slow growth rate, are the myriad of environmental stressors in the surrounding waters. Poor water quality, disease, and increasing sea surface temperatures impair a coral's ability to reproduce. Very few new juvenile corals means that frequently, the reef is being damaged faster than it can regenerate. By determining the habitat characteristics that will give larvae the greatest chance for survival, managers will have the kind of information they need to give reef restoration programs a head start. Instead of removing corals from one reef to fix another, new baby corals could be seeded onto the broken reef after a boat grounding and nurtured along to replace the damaged areas. For coral reefs struggling to survive, every little bit helps. The flats of Florida Bay. The beauty is matched only by their inaccessibility. For those who can navigate the maze of channels, sublime experiences await. But for those who are overly confident and lack caution, pain and penalty await. That is why Everglades National Park publishes the free Florida Bay Map and Guide. Because Florida Bay comprises 1/3 the area of Everglades National Park, because Florida Bay draws tens of thousands of boaters each year, and because parts of Florida Bay are the most difficult areas in the state to navigate, the Florida Bay Map and Guide must be read by anyone venturing into the backcountry.
Well, the changes I've seen since 1988, when I first came here, are more boats and more boat operators and more boats showing inexperience. Also, the boat technology has increased in leaps and bounds. So you're seeing boats going faster with less horsepower, going farther on less gas, and going shallower.
Florida Bay is not like a lake or reservoir with water held in a basin shaped like a salad bowl. Florida Bay is dozens of basins separated by shallow banks with winding channels connecting the basins. Even veterans with 20 years guiding experience in the Florida Bay backcountry take their time.
If you're from Michigan, you're used to fishing deep lakes or maybe even out in the ocean, whole different scenario back here in Florida Bay. You can't just drop the boat in and take off and go from point A to point B. You might be able to see point B from point A, but more than likely there's a shallow water area between those 2 points.
When boats run aground in the backcountry, they do great damage to the seagrass and hard bottom habitat in Florida Bay. Seagrass is a perfect habitat for marine creatures seeking shelter from predators and provides an almost endless food source. In fact, more than 70% of Florida's recreational and commercial fish, crustaceans, and shellfish spend part of their lives in shallow water estuaries among seagrass. Over 30,000 acres of seagrass in South Florida have been scarred by propellers. The Florida Keys have the greatest amount of damage to seagrass from boat propellers of any area in Florida. But as Captain Gary Ellis remembers, this wasn't such a problem years ago.
I've been fishing back there for 30 years, and I've watched the growth of more and more population in South Florida, more and more people owning boats. The boats are bigger. We have the introduction of the large center console boats, anywhere from 20 to 35 feet.
Captain Gary Ellis recommends a maximum boat size of 20 to 23 feet to venture into the backcountry, but 17 to 19 feet is preferred.
The boats I would recommend for this backcountry of Florida Bay are shallow water, shallow drafting skiffs. And there's a reason for that, because those boats are designed to run in shallow water and to do it with a minimum impact to the resource.
Pick up the free Florida Bay Map and Guide, and you can learn about the necessities to navigation in Florida Bay, including NOAA Chart 11451, compass, polarized sunglasses. A GPS is a good tool, but relying too much on a GPS while in Florida Bay is a big mistake. Learn to use your eyes instead. In addition, common sense and a couple of tips can go a long way.
One thing to look for when you're boating out here in Florida Bay is that if you have two mangrove islands and you're trying to boat between them, keep in mind that generally there is going to be a shallow bank in between those two islands, and hopefully you're headed for a marked channel. If not, you need to slow down and check the water first at idle speed with your engine trimmed up.
Channels in Florida Bay are mostly marked with stakes which show the way through the shallow banks. But these markers can disappear after storms and are only one tool for safe navigation.
Now, as I approach this channel, I'm wanting to line myself up so that I'm looking right down the throat of the channel, right between the markers to center myself. And now I'm trimming up because the entrances and exits to these channels are always shallower. And until you get into the channel itself, which I am now I'm trimming down where I can increase my steerage, and I'm going to run through the channel. And as I exit the channel, I'm going to trim up again.
The Florida Bay Map and Guide illustrates several natural signs to look for when approaching a channel to make sure that you are not in shallow water. 1. If you see wading birds. 2. If you can see mangrove seedlings. 3. If the water looks brown. These are all signs that you should steer clear.
And always look to your wake. Turn around and look at your wake, because that is an indicator of your impact to the sea bottom and whether or not you're operating your vessel properly through shallow water. If you look in your wake and you see brown, that's bad. You need to trim up or you need to slow down. If you look in your wake and the water's clear and the foam is white, then you're okay.
One of the main things you can do is read the water. You know, the old rules, brown, brown, run aground, green, green, the water is clean. And what that does is shows you, when you see brown, it means the water's super shallow. When it's green, it's a little bit deeper, normally deep enough to navigate.
Even though today's flats boats are built for very shallow water, they can still damage seagrass. Despite advances in technology, human error takes its toll.
This sediment out here in Florida Bay is very corrosive. So if you suck that sediment into your intakes of your lower unit, that sediment runs up through your water cooling system and into the power head of your motor. That sediment can also break down the metals of your motor.
Running aground and pulling debris into the lower unit of the engine can cause thousands of dollars in damage and personal financial loss. But the greater loss is the long-term damage to the bay bottom. Even if the boat propeller is not directly impacting the sea bottom, the wash from the propeller is very powerful and will dig holes in the soft sea bottom and cause lots of damage. Learning Florida Bay takes a long, long time. Even when boat captains have memorized every island and every channel, a storm or hurricane can change the bay. To make things even harder, powerful natural forces can change water levels in Florida Bay. In addition to tides, wind can move water around the bay. Water level can also be affected by rainfall. It's higher in the wet season and lower in the dry season.
If you go back in February, where you were in June, there won't be any water. The north winds have a tendency to blow the water out of the Florida Bay and resist the tide from pushing it back in. So where you were one day, a week later, you would not be able to get there.
Nothing can replace experience when learning the backcountry. The Florida Bay Map and Guide will help, but the Florida Bay boater must be eager to learn and assimilate new information. Talk with local guides and tackle shops, and be willing to learn from those who are more experienced.
Since 1998, I've probably seen about maybe one grounding every 2 weeks to a month. I mean, it's fairly common back there. Not only do people get grounded, but then they make bigger mistakes of trying to power off the flat or the shallow bank that they're stuck on, and that creates even more devastation to the bottom.
If you happen to run aground, which is something that nobody wants to do, you just got to stop. You've got to stop, turn off your motor, lift your motor up out of the water, and make some phone calls. You need to call a towing service to help you out of there. They remove and refloat grounded boats in a way that minimizes any further impact to that sea bottom resource.
If you run aground, do not try to power off. Do not call your friends and have them try to power you off. Those techniques will not work. When boat captains attempt this, the seafloor damage grows, and so do the fines. If you find yourself in unfamiliar waters within Florida Bay, or within any South Florida waters, the rule is, if you don't know, don't go. But if you must go, go slow.
If you're really a student and want to learn the backcountry, it would be good to take the channels and do a compass heading going one way and reverse. On each channel that you anticipate running, do the heading, do your compass heading and also your return heading. Do your homework and maybe take that compass and sit down at a table and draw some headings before you even leave the dock.
When you're traveling in the backcountry of Florida Bay, please be courteous to other boats and anglers that you encounter. As the number of boats in Florida Bay has increased, so has the probability of disturbing other anglers. It is also important to keep a distance from the wildlife. Whether spoonbills, bald eagles, or manatees, disturbing the wildlife is stressful to them and against the law. Captain Lane Goodwin, who grew up fishing and boating in New Orleans, took his time to learn Florida Bay. His method sets a good example to beginners.
So the way I went about it was going a couple miles each time. So the first time I went out, I went about a mile. I checked my charts, made sure I wasn't going to run aground, made sure I had plenty of water depth. Next time I went out, I'd go a little bit further and just kept going further and further and pushing the envelope each time. But each time I went, I would get a grasp on that first area even more than the first time. And as you go out further, you would get more and more confidence in what you're doing in navigation-wise. The main thing that I tried to do was to visualize where my boat was at all times on a chart. So each time I'd go out, I'd try to memorize an island. Then I'd visualize where I am on a chart according to that island or according to a creek or a canal. And that was the best way for me to learn. And it probably took me a good 3 years to be able to run all the way from Key Largo to Flamingo, which is roughly about 35 to 37 miles.
To venture into the backcountry in Florida Bay takes patience, caution, and expertise. The best thing to do if you are new is to pick up a copy of the free Florida Bay Map and Guide. It can be found in over 55 locations from Homestead to Marathon and at Everglades National Park Visitor Centers. The Map and Guide can also be found online at the Everglades National Park website. Whether fishing for snook, bird watching, or going on an eco tour, anyone who attempts to navigate Florida Bay is in for as much of a challenge as a treat. So please, do your homework before heading into the backcountry, and you will have a better chance of keeping your boat and the park safe from harm.